Welcome to the Math Record. Today I'll be covering the ICTM Regional 2020 Division AA Algebra 2, which I'll be covering questions 9, 15, and 17. As usual, I'll scroll down all 20 if you want to answer these questions by yourself, and I'll give the answers at the end. Okay, so that's all 20 questions. Let's begin with number 9. Let x and y be such that x plus y equals 5 and x cubed plus y cubed equals 2. Determine the value of x squared plus y squared. So what we need to know is that when you see like two variables like this, x cubed plus y cubed, you kind of want to put them together. So x plus y, and then you're going to cube it. But this is not the same thing. This is going to be x cubed plus y cubed plus 3x squared y plus 3xy squared. So for this to be x cubed plus y cubed, you need to take those terms away. So like this. And this equals x cubed plus y cubed, so that's equal to 2. So then from here, we could distribute out our 3xy, so minus 3xy. And then from here, we distribute out, we're left with an x, and then from here, we're left with a y. And then we know what x plus y is. That's 5, so this is just 5 cubed minus 3 times x times y times your 5 is equal to 2. So then we could just find our x times y, which is 5 cubed minus 2 divided by 3 divided by 5. And you get x times y is equal to 41 over 5. And then now to find x squared plus y squared, we will do the same thing as what we did as our cubed. So we have x plus y squared. So this gets x squared plus y squared plus 2xy. So we need to take away that 2xy to get x squared plus y squared. So x plus y, that's 5. So that's 5 squared minus 2 times x times y, which is 41 over 5. So that's 5 squared minus 2 times 41 over 5, which give us our answer, which is 43 over 5. And that's basically it. Okay, next question, number 15. Let x, y, and z represent positive integers that satisfy the system 3x minus y plus 12z equals 1512, 2x plus 8y plus 3z equals 1147. Determine the least possible value of x plus y plus z. So I noticed that the negative y and the 8y can be canceled out if you scale a negative y up. And then 12z can cancel out with 3z if you scale 3z to a 12z. So what we do is that we need to get a x related to your z and an x related to your y. So then we can plug in the values for x, and then it'll come out with some values for y and z, and we're going to see if those are integers. And then, so we're going to multiply the first equation by 8. So that's 24x minus 8y plus 12z equals 1512 times 8. And that should be 12096. And then we're going to add it to our second equation, which give us 26x. And then our 8y and negative 8y cancel each other out. And then, oh, sorry, I forgot to multiply by 12 by 8. So 12 times 8 is 96. So this is actually 96. Sorry about that. And then 96 plus your 3 is 99z. Then 1, and then 12096 plus 1147 is 13243. Okay, and now we need to get our second equation. So we're going to multiply our our second equation by 4. So that's going to give us 8x plus 32y plus 12z is equal to 1147 times 4. So that's 4588. So we're going to subtract the second equation by the first equation. So 8x minus 3x is 5x. And then 32y minus negative y is plus 33y. And then 12z minus 12z is 0. So then 4588 minus 1512 is equal to 3076. So now we have our two equations. So let's delete this because we don't need them anymore. And now we have these two. So what do we do now? Well, basically, all we have to do is just kind of make a table in our calculator, and then we could just plug in values for x, which comes out as z and y. So then we have, well, z is equal to 13243 minus 26x divided by 99 is equal to our z, and y is equal to 3076 minus 5x divided by 33 is equal to your y. So all you have to do is just kind of put this in your calculator and start spamming values for x. So it'll be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. So we just keep going until we find out a value for x that makes x, y, and z an integer. So, and the first value that should come out is 100 is 41. So then 41 times 5, and then 3076 minus this divided by 33. So we have 41, 87, and 123 as your x, your y, and your z. So you could check this. This is going to be your first point. I'm not going to like show my work of how that's going to happen. You're going to have to spam your calculator for that. So basically how we're going to check if this is the least possible is that if we have a value for, if we look at these two equations, if we have a value for x, which we're starting off, which is 41, for it to be an integer for the next one, while z also has to be an integer, you have to scale up x by 99, and you have to scale up z by 26. And then same thing here, x scales up by 33, and y scales up by 5. So what it looks like is for the next pair, for all these triplets to be integers, is that x has to scale up by 99, so plus 99. And then your z scales up by 26. And then from here, x could scale up by 33. And then y would scale up by 5. But what you kind of notice is that 99 and 33 are different numbers because you need to scale up x by one number and it scales up y and z by some other number, right? So what happens is basically when you scale up by 99, 33, you can't scale up by two different numbers. You just scale up by one number. So we gotta look for the least common multiple. So 99, 33, well, that's just 99. So we scale up x by 99. That means y would scale up by 3 times as much because 33 to 99 is 3 times, so plus 15. So then z is the 99, which is just scale up by 26. So the next pair is going to be adding a 99, adding a 15, and adding a 26. And then you just keep doing that over and over, and you keep getting your next pair, your next pair, your next pair. So, but what you kind of notice after this is that these numbers, since they're all positive, you're getting a sum that's bigger and bigger. So the smallest possible is going to be your first pair. And that's all you have to add up together. So 41 plus 87 plus 123, and that is 251. And that's your answer for number 15. So this is just a lot of like plugging into your calculator. Number 17. 2x plus 7 to the power of 101 is expanded and completely simplified. The coefficient of x to the power of 53's term is k. Determine the value of k. Write in scientific notation with four significant digits. So the equation to how to do this is if you want to write a polynomial and you want to expand it out, it's actually just the summation from x is equal to 0 to whatever that number is, which is 101. And then basically we have whatever that number is, which is 101, combination, and then combination with your x multiplied by the coefficient of your first one, which is 2, times the power of x, and then multiplied by the coefficient of the second one, which is 7, and then multiplied by the power of 101 minus x. So it's going to follow that pattern all the time. So it's just coefficient of the first one, coefficient of the second one, the amount of the exponent, the exponent, the exponent, and then you just start from 0. You always start from 0. And this is going to be the general equation of how to write those summations. But also I chose a really bad variable, but basically this is actually just 2x because this thing is 2x. So uh, so this is really bad, but basically this x are different. So I'm using this x just so we can represent an exponent because that's usually what x represents. So what we do is to find our coefficient for the 53rd term, we gotta have x is equal to your 53. So that's 101 C 53 times 2 to the power of 53 times 7. 101 minus 53 is equal to 48. And then you could just put this all in your calculator and see what it come out as. It's probably gonna be a really big number, so it's gonna be really bad, but it's gonna take a while. So 101 factorial over 53 factorial over 48 factorial, which is just 100 choose to 53. And then you get some kind of number multiplied by 2 to the power 53 multiplied by 7 to the power of 48. And then you get your first four digits, which you're probably going to see in your calculator if it can compute that much. So it'll be 5.872. So it's going to be your first four digits multiplied by 10 to the power of something. And all you have to do is just whatever comes out your calculator, you got to take the log base 10 of that number. So that number would come out as 85 point something, 85.7687, etc. So you only need the integer part, so it's just 85. And that is going to be your answer for number 17. Okay, and as promised, here are all your answers for all 20 questions. Well, thanks for watching, and I'll see you at the next math record.